Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh, ladies and gentlemen. Welcome back to another live stream. Hello. Okay, let me share the live stream in my Discord real quick. Let's see. Please join my Discord so you can get notified and you can vote for the next streams. Alright, let's see. Alright. Let's go. Yeah, that seems about right. Let's see if the live stream quality is fine. Seems about right. Yep. Alright, I think we're pretty much live and pretty much ready to start in. The mic seems like it's working, so that's nice. Okay, alright, let's start. Let's start already. Let's go. Okay, so let's go with C-Line. So the thing is, I have some resources here. I never really used WebGPU with C++, though I did use WGPU before, which is like the Rust implementation of this, which is used in Firefox. Dawn is used in Chrome. It's made by, I think, Google, basically. So there's a lot of resources right there, which is pretty cool. So I have just skimmed through them, but we're pretty much gonna be exploring this from scratch with kind of. I just skimmed through that stuff, and I did find this little interesting guide would also help with that. Though I do have experience with Vulkan, a bit of experience with OpenGL, so hopefully we could figure this out. So yeah, let's get started, I guess. Let's see. So let's go. Let's create a new project. Gonna go to C++23, and let's see. So I don't know what to call my project. Let's call it Coda Taco, and let's create this. Okay. Of course, I'm gonna be using CMake. And what's up with this? Clang format. Interesting. All right. Righty, let's go. Great. So now let's see. So here's my default CMake script. I just have CMake CPM. Sorry, I use this to actually add my dependencies. So let's try to add Dawn. I guess CPM add package, and let's see if that would work. I never really tried to set up Dawn before. So hopefully it would be pretty simple to do. Though Dawn is not in GitHub, it's used its own like Google source thing, so source control. Where is it? Let's see. There you go, Dawn source code. Dawn ref heads main. Great. All projects. There you go. Okay, so this is the actual, but this would like get all the projects, I guess. Interesting. All projects or Dawn. There you go. Okay, so this is how I guess you just copy this, and let's try to add it here, and I guess maybe. And can we say master? I don't know. Let's see. Get tag. Is that master? No, it's main. So let's see if that would work. I have no idea if that would work. Let's see. Okay, name was not provided and couldn't be automatically inferred. Okay, what if I don't give you this even? Was not provided. Alright, great. Okay, great. Okay, let's give git tag and let's give it the name too. Let's call this Dawn, I guess, and let's try this out. Git repository or URL. So we have a URL, so let's go with that. And problem with archive. So it's creating directories, great, downloading some stuff up and using src, downloading done, extracting. Problem with archive, read open file and recognized archive format. Interesting. Archive.tar. Extract on populate. Failed. Fetch content. Interesting. So it doesn't recognize the archive format for some reason. Okay, let's see how we could hopefully fix this. Like I never really used Google source control. I usually use GitHub, so this is weird. Let's see, Dawn src. Recognized archive format. tar xf. Interesting. Let's actually search for this up. Let's search for this up. Let's see if we can find something about it. Alrighty, using the following problem with archive. Let's see. It's purely accidental. Interesting. Alright, let's see. Tree, parent. Okay, what about CPM, CMake Google source, I guess? Let's see if we can find something. Nope. Interesting. What about the closed ones? Interesting. Let's see the wiki and let's try to figure this out, hopefully. More snippets. So yeah, it's all GitHub. Let's see. So this is URL. This is zip. Though this one seems like it's wanting tar xf for whatever reason, which is crazy. Configuration options. git tag version. Yeah, let's see if we could figure out how to get a zip from this, because it seems like it's given us star xf for whatever reason. So Dawn repository. Okay, let's see how to do that, I guess. Public commit, third party deps. No idea. Let's see. Google source. Tar xf. Have you tried WebAssembly? Not really. And welcome. No name. So my brain have stopped there for a second to see what is the name. Anyways, so Google source tar xf. This is really not useful at all. Oh well. glib. Yeah, I know. That's not helpful at all. Let's see how the other ones have actually installed it real quick. CMake, C standard. Git submodule add Dawn. Didn't I do the same exact thing now? Yeah, kinda. To some degree. Git tag main. Oh, I'm saying git tag. Oh my god. Could it be the problem? Let's see. Build samples. This is weird. Let's clear all and try again. Problem? No, it's still same stupid problem. Alright, well, great. Alright, what if I added this? I don't think this would fix it. Yeah, no. I knew it. Alright, I guess we're forced to maybe use git submodules and hope that it actually works. Archive.tar. Otherwise, I'd need to figure out like how to get Dawn archive thing, I guess. Like if I said maybe .zip or something like that, would this help by any chance? Not really. Yeah, no. Response code said there. Okay, interesting. Alrighty. Well, what about Google Dawn? Well, let's just say Dawn git repo. Hopefully they have like a GitHub mirror or something like that. That would be nice. Oh my god, 2014, what? Yeah, they only have Git at Google, I think. Righty. 2019. That is crazy. Amazing. Oh well, benchmarking. Maybe we could try to add like /archive and hope that it works or something. Let's see. Okay. Oh, hold on. What is this? Oh, hold on. I see something here. Interesting. Okay, I see. That's nice. So maybe we could copy this link. Is WebGPU layered on top of an existing graphics API like Vulkan? Yeah, pretty much. It's using either Vulkan or OpenGL, or basically depends on the platform, which it even uses Metal, DirectX, etc. So that's why it's actually cross-platform. So you could basically make your code once, make your application once, and then basically run it everywhere, even on browser. So yeah, HTTPS. Okay, let's hope this actually works. I'm gonna add this instead, and let's see, would this help by any chance? And I think we have figured it out. All right, so it's adding it. It's gonna take some time. Oh my god, let's go. So CMake error, Dawn using Sperry headers, Doxygen not found. Okay, so it didn't find Doxygen. Great. So there was, in the other tutorial, we did find something interesting, which is this guy right here. So let's see if this would help by any chance. I mean, CMake is still running. Okay, it's running fetch Dawn dependencies now, which is nice. And since it didn't find Doxygen, just skipping documentation altogether. I don't think I need documentation though. So yeah, as you can see, setting this variable seems like it would basically make it so it does go ahead and fetch the dependencies itself, which is amazing. Let's go. And I think you'd need Python too here. But there you go, build files have been written. Okay, so that was pretty fast. It's kind of making me doubt that it actually got installed. Weird. Is it really that fast? I don't think. But let's see. Well, let's actually link this first. So you say target link libraries. WebGPU Dawn, GFW, blah blah blah. Yeah, fine. Just let's keep going. Great. So I guess let's try this out, and it should hopefully link it. Well, not link it, right? Hold on. Cannot specify link libraries for oh yeah, my bad. So this is gonna be project name. This is basically a variable which would resolve to the project name, which is in this case called Otaku, just so you could easily change the project name, and then it would basically oh yeah, I see. I'm gonna change my defaults later on for CMake, but anyway, for now this is good. Should be good to go. Okay, let's see. Alright, so it's finished. Let's try to run this. Okay, let's go. It's actually building Dawn from source. And while it's actually building, let me tell you why you would need to build, or why it's better to build from source. Because we could actually, like, the project is self-contained, and also it would work hopefully on all platforms, since we're not like fiddling with the file system and fiddling with like binaries and like DLLs and SOs and crazy stuff like that. It's all right here. And also the fact that we're using CMake directly, we're probably gonna have like a lot of cool CMake variables that we could use to control the build process of the library, to tweak stuff. I mean, let's go to build execution, CMake. Of course, you don't need C-line, like you could just use whichever IDE, pretty much. As you can see, it's just CMake options. These are my options, seems like. Hold on. Yeah, these are my options. I'm using Ninja for generation. And toolchain is probably GCC. This is the build directory, and yeah, pretty much. Okay, let's look at the cache variables. Yeah, there you go. As you can see, this is all the variables that can tweak to actually control the build process. Actually, not the build, yeah, the build process and the generation, which is pretty cool. For example, if I want to include benchmarks, let's say the Dawn benchmarks, I could just, say -d Dawn build benchmarks equal on, and there you go. Samples, for example, samples by default are on. I could turn that off if I want to, which I'm probably gonna do, but yeah, as you can see, it's pretty cool stuff. Enable Vulkan. So as you can see, for my platform at least, Vulkan seems to be enabled by default, and OpenGlass and GL too. For example, DirectX of course is not enabled for my platform by default, because, well, I'm on Linux right now, so that makes all sense. Don't GFW there, so here you could actually specify GFW directory. And by the way, I don't really need to check out if the build have finished. I already know if it have finished or not, because I'm hearing the fan of my computer going crazy. So when it shuts off, I know that it's the build have finished. So that's nice. Okay. Don't target macOS. Great. Use X11. Enable GLSL lang binaries. Cool. And also the GFW stuff. Now basically, Dawn also includes its own stuff, and then its own stuff I could control the variables of it. For example, it includes GFW, so I could control the GFW process too, build process. So that's pretty cool. There's also Tint, which is like the compiler of WGLSL lang or something like that. I don't really remember what their language is, but basically have a custom language. So of course they have a custom kind of compiler, or I'm not sure if you can actually call it compiler. Maybe it's just a transpiler kind of, because essentially it can convert your code into SPIR-V, and also for Vulkan, for example, and it can like convert it into GLSL, so it can feed it, for example, to OpenGL. It can convert it to MSL if it's using Metal for macOS, etc, etc, etc. Crazy stuff. Though as you can see, it's taken some time indeed. Seems like it's compiled some Vulkan stuff. Okay, let's go. There you go. Shader module vacay. Interesting. So as you can see, it takes some time, but it really pays off. The fan spinning up and down. But it really pays off, because I'm gonna show you that you could actually, since the source code I have it here, I basically have full control over what's going on in the whole build process. I also have full control on the debugging side. For example, I could just put a breakpoint and then just see what exactly is going on in the library, like the source code, what the code is running, and what it's doing. So that's pretty cool. Anyways, also my repo wouldn't contain anything. Like when I actually publish this, let's say in GitHub, it would only contain the actual files of my projects. So this build is actually just generated. So I will only have this Clang format, which basically set up my formatting stuff, and I'm gonna have this CMake list. And by the way, this Clang format is just like for consistency. Like if you are a team on the same project, it would basically make sure you're using the same formatting style. And yeah, here's our source code. Anyways, let's try to get something going. So as you can see, I think right now we have actually built the library. Now let's see what we could do. Okay, we got WebGPU, okay, / WebGPU.cp. I'm gonna try to use the CPP wrapper, though there is like the API itself is just C API, though I think the implementation is C++, but the actual API itself is C. So it's basically, you could use it in whatever language you want. But I'm gonna try their C++ wrapper. If it doesn't work for me, I'm just gonna go back to the C API there. So yeah, all right, running some tests, weird crazy stuff. Anyways, I can disable it, but anyway, who cares? All right, let's see where we can start. Let's try to go through this guide real quick. So this is introduction, blah blah. But yeah, let me actually document. I know exactly what he's talking about here. So there you go. So WebGPU, this is like the backends. For example, it could use Vulkan, DirectX, or Metal, depending on like which platform and which APIs is supported, basically. And of course, these APIs actually contacts the hardware directly, like the drivers, basically. Anyways, why WebGPU? And of course, from the driver to the GPU, of course, so, or the CPU, depending, like it could be in an integrated CPU or just like a software implementation, but who cares anyways. Why WebGPU? So reasonable level of abstraction, good performance, cross-platform, standard enough, and future-proof. Okay. Alrighty. It's actually the only graphics API that benefits from all of these properties. Yes, the WebGPU API has been designed primarily for the web as an interface between JavaScript and GPUs. This is not a drawback, since as of today, the requirements in terms of performance for web pages is actually the same as for native application. You can read more about why I believe that WebGPU is the best graphics API to learn in 2023. Okay. Yeah, it's kind of nice, though. I like the fact that it's similar to Vulkan API, which is pretty cool. So yeah, why C++ then? Shouldn't we use JavaScript since initial target WebGPU, or C because it's the language of the WebGPU.h header we'll be using, or Rust since this is the language in which one of the WebGPU backend is written? Yeah, WGPU. All of these are valid languages to use WebGPU with, but I choose C++ because C++ is still the primary language used for high-performance graphics application, video games, render engines, modeling tools, etc. The level of abstraction control of C++ is well suited for interaction with graphics APIs in general. Don't worry, I'm not going to read the whole documentation. I'm just reading these highlights, basically, for you guys. So graphics program is a very good occasion to really learn C++. I will only assume a very shallow knowledge of this language in the beginning. Anyways. Anyway, blah, 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 whatever. Getting started. Project setup. We have already done this. I think this project uses WGPU, not Dawn. But they should be very similar. It's hard to name people that actually like C++. Okay, let's see. Linux. Right. Mac OS. Brew install CMake. Add executable. Okay. Building. Recommended extras. Yeah, this is interesting. I like this. Compile warning as error. So let's add that to my default CMake, I guess. So I like that one. This is something that I learned about CMake there. So where is it? Yeah, there you go. So this is just to like enable C++23 for that specific target. And also here what I'm doing is, yeah, I'm disallowing C++ extensions, so I make sure I'm not using any compiler extensions, basically. Anyways, so compile warning as error on. Right, on, there you go. And target compile options -wall. Okay. Though you could go with this guy. If MSVC, then go with /w4. /w4 is kind of much, it's crazy, but yeah, -w wall, -w extra, -pedantic. I don't know if I really want to go with these ones though. They're pretty too much, but yeah, okay. -w extra, -w pedantic. I may remove these, but of course this only works for other compilers other than MSVC. So okay, let's go. And if MSVC, then we're gonna go with /w4. Though I really think that /w4 is too much, but anyways. dash ww extra pedantic. So if I publish this into GitHub and it doesn't work for you because of some crazy errors, if you are on Windows using MSVC, then you probably want to remove this one. Anyways, let's see. So I think that's it for that one. Let's see what else. And yeah, if you're on Mac OS, you gotta do this weird stuff that I have no idea about. But I'm just gonna put it. Why not? If Xcode project name properties generate X scheme and scheme enable GPU frame capture mode. Okay. All right, what else? Let's go. Opening a window. Installation of GFW. Okay, I don't really like the setup of CMake in this tutorial. They're just using zip. Crazy stuff. Anyways, that's subjective, I guess. Target link libraries. Include GFW. Alright. Alright. So everything good now? So we have WebGPU CPP, and let's see. I've been skimming through the Dawn repository, and I've seen some files right there here. Pretty interesting stuff. Includes Dawn. There's native platform wire. Let's go native. Ooh. Not really this one. Let's see. I missed something. Yes, WebGPU. Yeah, there you go. Okay, so there's WebGPU CPP, and there's also this WebGPU GLW. And this actually gives us some nice helper functions, which is pretty cool. And it also already includes the WebGPU CPP. So we could go with this one. And the nice thing about this guy, this WebGPU Dawn, it seems like it includes GFW by default, though you could probably disable it if you really want to, but we're just gonna go GFW, who cares. WebGPU GFW, okay. Alright, so instead of WebGPU CPP, let's try WebGPU GFW instead. And let's go. Okay. Now let's go back to the okay, so we're gonna initialize GFW and terminate it, blah blah blah. We'll create a window, destroy window. And of course, we need to set the API to none, because otherwise it would create a like an OpenGL context, because that's what the library is made for originally. But anyways, GFW pull events. Okay, great. So let's do that. I'd like to first of all create a class called app. Okay. Okay, great. I'm not sure. Well, let's just create an simple, or like an external, sorry, in its own file basically. So C++ class, let's go with app. Great. And oh, let's actually make this into a directory called src. It's gonna refactor that stuff. Oh my god, don't tell me it's gonna search everything. Okay. I would have been already done if I just done it manually. Anyways, let's see. Did it really fix those? Let's see. Add executable. Yeah, I think it did, so that's nice. Okay, so this would go into the app.hpp here, and yeah, and app.cpp here. Great. Let's reload CMake. Okay, great. Okay. Can I disable this for a second, honestly? But anyway, who cares? So now let's see what we could do. So basically, public app void run, no. let's just go with these two guys for now, I think. And yeah, generate definition for constructor and generate definition for deconstructor. Okay, great. All right, let's see. So first we're gonna have like a GFW window, private GFW window. Okay, so for GFW window, interesting. So oh my god, look at that. Look at that GitHub Copilot doing the job. No, GFW window. Okay, the other thing would be, yeah, good. And here we're gonna say GFW init. And what's up with this? Why don't I have GFW init? Interesting, why? Oh, I think the WebGPU GFW doesn't really include GFW itself. I think so. Yeah, probably. So let's include it ourselves then. Fine. Include GFW. File not found. Okay, do I have to include GFW myself, I guess? Interesting. I've seen that it actually have included that. Weird. Okay, this seems to be, yeah, there you go. So it's basically like this. So it includes GFW, great. So GFW init, nice. Alright, what else? If not GFW init, okay, great. So if not GFW init, let's throw a runtime error failed to initialize GFW. Okay, great. What else? So GFW terminate. Let's go. And now we need, I think GFW hint, or yeah, hint client API, no API. And what's up with that again? What? Okay, it's called, I guess, window hint. Yeah, I see. A window hint. GFW client API, no API. And now let's create a window. And if not window, then we're gonna throw. And yeah, that seems about right. Great. Great. If not window, GFW terminate, please. And well. So honestly, you know what? I'm not gonna care about these stuff because it's gonna drive me crazy. Anyways, like I'm not gonna care about exception safety, I think. So we could easily go with this. Anyways, so we got here GFW create window, and then you got GFW destroy window. Great, let's go. Nice. What else? Now we gotta get the loop running. So while not GFW window should close, GFW pull events. So pull should close const, and let's actually generate this and return GFW window should close window. Let's go. Great, and then we got GFW pull events. What's happening here? Should be marked no discard. Okay, great. And what else? We got pull events. Nice. Void. Okay. Void pull events. Let's go. Generate and finish. Oopsies, not pull events. What the? Pull events? Pull events, alright. Let's go with this. And yeah, So now here we're just gonna say GFW pull events. Anyways, so method can be made static. That's true. I guess. Okay. So now let's just say app. Or honestly, you know what? Let's not make it static. Go back. Oh well. Yeah, don't make it static. Anyways. Alright, so what's up with this? A known type name. Okay, great. Let's include app, I guess. App.hpp. What did I call it again? App, yeah. But I have to use this. Oopsies, what the? There you go. And then while not app.should-close, we're gonna pull events. Okay, interesting. Alright, let's go further, I think. Well, let's see if this actually works. Should work. There you go. We got our first window, and when it closes, it closes. Great. Next up. Okay, he's using WGPU native. He's using the Firefox implementation, though Chrome's implementation I think is better currently, I guess. So as you can see, these two implementations still have some discrepancies, but they will disappear as the WebGPU specification gets stable. To make this integration, okay. Comfort of Dawn. So the pros of Dawn. Dawn is much more comfortable to develop with because it gives more detailed error messages. Nice. It is in general ahead of WGPU native regarding the progress of implementation, but WGPU native catch up eventually. The cons, although I reduced the need for extra dependencies, you still need to install Python and Git. The distribution fetches Dawn source code and its dependencies. The first time you build, you need internet connection. The initial build takes significantly longer and occupies more disk space overall. Anyways, target link libraries. Oh, he's adding geo. Oh yeah, that's okay. All right, testing the installation, descriptors. Okay, so first we're gonna create a WebGPU instance, and then we're gonna check WebGPU instance, and then we're gonna destroy. Okay. So here he's actually using the C API, not the C++ API, so we gotta figure that out. That's gonna get crazy. But let's see. Hopefully GitHub Copilot can help us with that, but let's see. Alright, so WGPU instance. And I can't believe I'm recording at 3 a.m. and there's these annoying stuff. But anyways. WebGPU instance. Okay, so this is coming from CPP. Okay, great. Hold on, just gonna make sure that I didn't miss anything there. Okay, great. App CPP. If not, GFW init, GFW window hint, pull events. Okay, so what we have done. So yeah, right now we include the instance. So how are we gonna initialize it right now? So instance equals WGPU create instance, and here you could actually pass it the descriptor. Okay, great. So let's try to add a descriptor, I guess. Okay, proc address. Ooh. Okay, so here we gotta pass it a const pointer to an instance descriptor. So let's try that out. So instance descriptor, next in chain, and it have features, instance features. oopsies, feature, instance features. Oh, it's called instance features. Okay. Okay, and you could actually get the instance features. Timed wait any max count, timed wait any enable. No idea what's these. But anyway, I don't think we need anything here actually. Yeah, for now. So what else? Yeah, as you can see, well, it indeed passes that. But I think probably null PTR should be fine though. But anyways, let's just go with this. And let's just call, let's give it the instance descriptor. Okay. Or honestly, keep it as descriptor. And I'm just gonna, I guess, scope that. Yeah, I need to pass a reference there. And let's just scope this, because we're gonna have a lot of stuff here. Okay, great. So what's up now? If not instance, display the object. Okay. So now if not instance, throw std runtime error, failed to create the WebGPU instance. What else? Let's try to see out. Let's try see out. WebGPU. Oopsies, not that. From iStream, let's go. Let's just try to see if this would work by any chance. Yeah, they didn't implement that. Interesting. Git. So you could acquire something and request adapter, process events, and create service, and wait any. Okay. So, alright, let's see if this actually works by any chance. Shift F9. Okay. Great. So no exception was thrown. So I think we have successfully created our first WGPU instance in C++. So destruction and lifetime management. Destruction and lifetime management. So yeah, if you're using the C API, you're gonna deal with references and ref counters and stuff like that. We probably don't have to do it since we're using the C++ wrapper, but well, anyway. So in order to handle between implementation, okay, anyway, let's go to the next step. So which is actually getting an adapter, requesting an adapter. Okay. So this is in JavaScript how you would do it. It's basically an async function which you await it, but yeah. Request adapter. Okay, let's see how we could do this. Let's see. So instance.request adapter. So it needs request adapter options. You could pass it a callback and then user data. Okay, interesting. Righty. Ooh, what the is happening here? We can wrap this in a request adapter function that mimics a JS await. Okay, anyways, I see request adapter. User data. Yeah, it would have been nice if it uses C++ async, but seems like it doesn't, so you just give it a callback essentially. Request adapter options. Alright, let's try to make this work, I guess. So an adapter request enabled. Status success, adapter, call to WebGPU request adapter procedure. Equivalent of navigator.gpu. What is that even supposed to mean? In theory, we should wait until it's been called. Okay, let's try to figure it out. So request adapter, and seems like GitHub Copilot have done something here. Let's see what's up with this. It's for some reason calling this weird stuff. So it's getting the limits and then it's trying to crazy. Anyways, then yeah, it's missing the mark entirely. It's missing the mark entirely. Okay, so let's see request adapter. Here we got adapter options. We need to pass it the options, and here we need to pass it some callback. WGPU request adapter callback. Okay. So let's say request adapter callback, I guess. Or let's say on so what that callback would get actually. It would get the status, and so callback called by when the request returns. Okay, on adapter request ended. On adapter request ended. Okay, let's call it that, I guess. On adapter request ended. Or let's just call it that, on adapter request. And what else? So we passed it a callback. And then we're gonna pass to a user data, and for that I'm gonna just pass it, I think, app, like basically this, which is the actual class here, the actual instance, sorry. And let's see, we gotta create that WGPU adapter callback thing. Oopsies. Okay, so this is basically a function type, and yeah, it takes this guys right here. There's here WGPU function attribute. Okay, let's try this out, I guess. Let's see. So let's say on adapter request. And yeah, it seems to be accepting it. And then here we got, so Copilot is having something here. What he's doing. So yeah, that's right. So he's static casting the app. That's correct. Because we passed it here, and then it checks if it's unavailable. Yeah, it seems to be missing the mark afterwards. Oh, I see why. Well, I guess we could make this like static inside the class, I guess. But yeah, Anyway, let's just take this from here and let's put it as a static function. Where we could do that, well, yeah, let's just say app on adapter request, create new function. And yeah, we have created this right now, message, user data, and status. Great. So essentially, if status equal to error, then we're going to see, and we're basically going to throw an error. I don't think we can throw here though. This is like a C callback kind of thing. So yeah, I don't think we can actually throw exceptions here. Though I guess it's worth a try, but well, anyways, fine. Okay, so what else now? Unavailable. No available adapters. Well, let's see what he have done here. So he's checking if it's success, else he's basically yeah, he's giving it the adapter. Great. Though he's using here reinterpret cast. Interesting. Why I'm using static cast then? No, I don't think static cast would work here. Yeah. Request ended equal true. Interesting. So I see what's happening. So basically this would actually get called when the request have done. I don't think that would take much. Call to the WebGPU request adapter procedure. Oh, so I guess maybe that's for web only or something? I don't know. Anyways, let's just give it an adapter now. Let's go to app HPP. Let's give it WGPU adapter. Let's go. And let's see what we could do now. Alrighty. And also here we need this options, basically. And options, force fallback adapter, blah blah blah. There's even power preference. Const. I think this should be const, right? Maybe? Not really. But why it's not accepting this? Oh yeah, I see. WGPU request adapter options. Okay. So we have backend type. Okay, so you could choose the backend, have compatibility mode, compatible surface. Okay, so this could be used to check if the surface like to get an adapter that is actually compatible with the surface. So we have to create the surface before actually the adapter. Force fallback adapter, next in chain, and the power preference. Let's go with the highest performance, I guess. So WGPU power preference. So you could check low performance. I'm just gonna go with higher performance. So it's gonna choose the best physical device when it comes to performance. Yeah, basically. And here we gotta need the compatible surface though. And here we gotta pass it the surface that we have created. But we haven't created it yet, of course. Cannot initialize a parameter of, I guess maybe I have to possibly give it that. Must be called non-static. I should make sure that it's static. Hold on. Yeah, let's go. What about now? Yeah, seems about right now. And let's actually create the surface though. So let's actually add it here. So before the adapter, WGPU surface. There you go. And now let's see how we could actually do this. So surface is equal to WGPU. Well, create surface. I mean, we have actually added WebGPU GFW. So it have create surface for window in the namespace WGPU GFW. Okay, great. So WGPU GFW creates surface for window, and then you could basically pass it the surface, I guess. Oh my god, let's go. Yeah, pass it the instance and the window. And yeah, I think that should be right. Does the necessary setup. On failure, returns null on failure. Null WGPU surface on failure. Okay. So if not surface, then we're gonna throw an error or runtime error, exception basically. And yeah. Now here compatible surface. Yeah, the order is not correct. Okay. And yeah, that's how you basically make sure to get an adapter that is compatible with your surface. Nice. Righty. So with this out of the way, if it's WGPU request adapter success, well, it seems like it got changed maybe. Well, oh, I see. Okay, I see. So we could actually cast that this WGPU request adapter success thing. So let's cast this to WGPU request adapter status. And yeah, there you go. So cdcar failed to request adapter return. Okay. Well, else we're gonna do this. Well, actually, let's say not equal to success, and let's just go with this, right? Now, if it's success, we're gonna say app adapter WGPU adapter acquire adapter. Okay. I guess adapter. Like, yeah, we cannot actually like directly give it the adapter because like it's C type here. So that's interesting. Though, can't I just like, I guess, say this? I mean, this seems fine too. So, okay. The WGPU adapter. Okay, great. So after this, let's try to see out maybe adapter, and let's try to get something. So we could get the limits or get the properties, for example. Okay, great. Let's try to get the properties, I think. Huh. What this returns? Oh, yeah, it returns through a pointer, seems like. Gotcha. So WGPU properties, adapter properties. Great. Give properties, properties, and then we could actually go ahead and check out the name that we have chosen for the adapter. Let's see if that works by any chance. All right. Oh, I see. Let's go. All right. So, yeah, there you go. We have chosen an actual adapter. And this stuff, you probably won't get it like me, because you probably don't have Vulkan validation layers on. And if you want that, like me, you could actually go ahead, download the Vulkan SDK, and after that you're gonna have like vk-config, the Vulkan configurator, which you could actually run, and there you go, you're gonna get this guy. Now you could choose whichever extension you want, and you could use this for debugging, and basically, yeah, as long as of course WGPU uses Vulkan for your own system. So we could, for example, go with validation and check if WGPU is doing something wrong in terms of Vulkan, I guess. Let's try that out, I think. Let's go. Let's see if the... Okay. Yeah, there's no validation errors. Interesting. I remember WGPU had like thousands of errors. Or maybe we just didn't do enough yet, but well. Let's go with API dump. If you go with API dump, you're gonna see all the calls made by WGPU to Vulkan, which is pretty cool. As you can see, we're creating a Vulkan instance. Yeah, it's passing null to that stuff. Nice. This is the extensions it's passing. Debug utils, xlib, xcb. For some reason, it's passing both. And also Wayland. What? Why? Yeah, anyways, okay. And then calling create debug utils messenger, enumerate physical devices, and get physical device properties. This is very interesting. Get device key family properties, 2. Great. I'm just super curious. Device features 2. Format properties. Oh my god, that's too much properties. Yeah, it basically fetches all the stuff. Okay, great. Anyways, so yeah, at this point we got an adapter. Lovely. Love it. So, and in fact we should probably maybe, let's see. I mean, honestly, this should be fine, I guess. Success, then message and return. Now, honestly, after request adapter, I gotta make sure that it's not null. So if not adapter, then we're gonna throw fail to request WebGPU adapter. Okay, great. Now, I think we have done it. Okay, great. I'm just gonna disable these for now. Anyways, so we got the adapter. What's next? Let's see. Assert that requests have ended. In theory, we should wait until onAdapterReady has been called, which could take some time. Practice, we know that when the WGPU instance request adapter function returns, its callback has been called. But the thing is, I don't understand, like, why it's not async then. I have no idea. Anyways, in the main function, after opening the window, we can get the adapter. Okay. What? Request adapter? Oh, I guess I've already done that, no? Oh yeah, it's just using that function. Okay. An adapter release. Do we actually need this stuff? I don't think we do. Or is it not REII or something? Let's see. I mean, these are private, so object base. I would guess it calls this destroy on destructor. I would guess so. But we could actually try something interesting here to make sure that's the case. We could say API dump, and we could see, like, when the application, does it destroy the handles or not? If it does, then we're indeed doing it right. Ooh, it doesn't. Interesting. So how we could actually destroy these? should close. Let's see. So if I say adapter create device, I don't see a destruction. Yeah, I'm not sure how to destroy these honestly, but anyways, who cares? For now it's fine. So okay, next up it's probably creating device. Let's see. So compatible surface. By the way, this compatible surface matters in desktops, but it doesn't matter when it comes to mobiles, at least for Vulkan. I'm not sure about the other ones. GFW3 WebGPU extension. Okay. Let's see. Target copy binaries, blah blah blah. Anyways, good. So we don't need any of these. It's already included. All nice, cool. Allocate memory. WGPU adapter enumerate features. Enumerate feature. We don't need that, but yeah, we could try that out. Why not? I guess. Let's see. So adapter enumerate features, and then we give it a pointer here. WGPU. Probably adapter features. Come on, bro. What this gives? Feature name? What? Weird. Feature name. Richie. Let's see. Adapter. Or I guess WGPU feature name. Which is ZUN32T. What? No type named. But this is like a UN32. Oh, like is it? Oh, interesting. It's just like an enum. I see. It's an enum of things. Gotcha. So let's try to debug this real quick. Come on. And let's see what features we have there. Of course undefined right now, but if I step, what? Okay, let's try to do something here real quick so we could actually see the features. Oh well. Dot I don't know, let's just say something. So we could just put a breakpoint here so we could actually inspect the features that exist. Come on, bro, super slow. Let's go. Okay, so features, it seems to be set to depth clip control. What? I guess it's only one flag for my case, maybe. I don't know. But anyways, enumerate, but it says features and it's pointer for some reason. Oh, it actually returns like a size T. Well, if we check this out, what it does exactly, yeah, what it does. Let's see what you actually do, because I'm not sure how this actually works out. Let's see. Okay, so here where I was talking about, I could actually go into the source code of the library and see what's happening. So WGPU adapter enumerate features, feature name, features. Okay, it's getting the adapter and it's calling this guy. Let's see what this guy does. Okay. Alrighty. I lost it already. That's crazy. Anyways, never mind for now. Anyways, let's not waste time on this. Damn. Okay, well, never mind. Let's see what else. Conclusion. Alright. Let's go to the device. Yeah, right now we need to request the device, and it's pretty much similar thing, which is very annoying. Could probably make some helper function, or maybe even there isn't already a helper function that we haven't seen. But anyways, actually, good question. Let's see. If we have a look into this, I guess there was samples, right? Yeah, I've seen those samples somewhere in this repo. Could it be in test? No. Interesting. Yeah, it doesn't seem like. Yeah, I've seen it somewhere, but I have no idea what's happening here. Tint bug tracker, code of conduct. Let's see Dawn samples, because I'm pretty sure I've seen it somewhere. Yeah, there you go. It's NSRC Dawn samples. Let's go. Alright, let's find out. CPP hello triangle. It's using global scope. Okay. So is there some way to do that? Let's see. So create CPP Dawn device. So sample utils. So maybe it could be in sample utils or sample utils.cpp. Okay, let's see. Create sample utils. Great. Print device error, device lost callback. Create CPP Dawn device. Let's go. Ooh, crazy stuff. Oh, by the way, we could actually set GFW error callback. Let's go. Anyways, return WGPU device. GFW window hint, create window. Instance descriptor. Timed wait, any enable. Okay, next in chain, power props. Preferred adapter, create device. Next in chain, WGPU chain struct. Crazy stuff. And oh, interesting, it's getting the backend procs for some reason. So after creating the device, it's doing this, Dawn native get procs. And it gets Dawn proc table. Because, well, in Vulkan at least we have like this kind of device proc addresses, which is like loaded directly from the driver, so you could call into the driver directly. So maybe this is it. I don't know, but that would be interesting to find out. But hold on, how did it actually create that thing? I don't get it. Like how it find the adapter. Weird. Righty, let's see. So what I called request adapter. Okay. What? I'm confused. Okay, it's calling this enumerate adapter function. Interesting. Oh, hold on a second. Request adapter. Okay, hold on. So what if I said instance.enumerate adapters instead, I guess? No, it doesn't contain that. Interesting. No idea. But it's using it here. Where's the instances being done? What? There you go. std make unique non-native instance. All right, I see. So this way we could actually support web, but if we don't really care about web, in fact we could probably go with this non-native thing here, which is quite interesting. Yeah, very, very interesting. I don't know if I want to sacrifice web. Anyways, fine. Anyway, let's just go with whatever they were doing. So here right now we're gonna request a device, and what it's doing here. Okay, it's calling WGPU adapter request device, and device request ended. Okay, great. So let's add a new callback. Static void on adapter. So let's see. Adapter dot. Okay, and let's say request device, and essentially it contains a descriptor, a callback, and the user data. Great. So the descriptor would be descriptor, the callback would be on device request, and this. Okay, great. So for the descriptor, we're going to create a new local descriptor. Let's go. Oopsies. And yeah, do we need to actually set anything interesting here? We got the default queue descriptor, device lost callback. Ooh, okay. User data label. This is for debugging. Okay. Required limits and required features. Okay, great. Let's see what they have actually done here when it comes to the descriptor though. I guess nothing for now. Actually, here you go. So he gave it a label, no need. Features, no need. And label, no need. And then a device error callback. Alright, use a debugger, which I recommend. This is like a very rare kind of error. When it happens, usually apps just crash because it indicates like you have basically kind of like the driver have got like an irrecoverable error. Not really. Well, anyway, never mind. So let's just try to make this work now. So kind of similar to an adapter request, but it would be on device request, I think. But of course, this takes in a request device callback, which takes this. And let's go to here. Let's put this guy. Great. Now app static cast. If static cast, okay, great. Failed to request a device. Well, this would be device status, and here also device status. What else? Out of line does not match in declaration in app. What? Oh. Hold on. Did I? Where is app.hp? There you go. Yeah, I didn't update this too, so there you go. Now is not implemented. What? Static void. Alright, implement it. Let's see. Oh, why it calls it on adapter request? What the? Are you kidding? Oh, I have actually removed. I see. Crazy stuff. Okay, on adapter request, and let's say static void on device request, and there you go. Okay, so on device request here, well, of course we gotta also need a device now, so WGPU device and device. Nice. So that's it. Okay, now we're gonna say device is WGPU adapter device, I guess, and no matching constructor. Oh yeah, this would be device too. And honestly, maybe I don't even need that one. No, I do. Oh, okay, great. So I think that should be it for requesting a device. And then essentially what I could say, well, let me actually put this in its own block. And then I could basically check. If not device, then throw runtime error. Let's go. Alrighty, nice. Now, what's next? Let's just try to make sure that this actually works. Without an error, of course. And yeah, it seems like it. And it have actually, interestingly, created a lot of cool stuff. Okay, so it's created the device, I think. Probably. And it have created the command pool, allocated some command buffers, begun the command buffer, created some descriptor sets, layouts, and the pipeline layout, interestingly. Nice, lovely. It's very interesting to see what the Vulkan calls are really behind the hood, like under the hood. That is very cool. So yeah, we got a device, I think, at this point, which is pretty nice. Now let's get to the next point, which is a command queue. Queue operators. Okay. So when you create a device, you create with it, like you get with it a queue. You create with it, the queue, or you request with it the queue, and then we just get a handle to those queues. Well, in WGPU or WebGPU, you only have one queue, so we're just gonna get the queue here. So adapter. So we're just gonna say queue. There you go. And in fact, no, not that. Let's say queue.get queue, I guess. There you go. And of course, let's actually declare that. So WGPU queue. And let's go. Nice, amazing. So yeah, we got the queue now. What's next? So you have three functions: submit and write buffer and write texture. Makes sense. We also find a WGPU queue on submit work done procedure. Okay, let's do make sure things happen as expected. WGPU queue submitted work done. Which work it's gonna submit? Oh, it's just gonna set the callback. Okay, great. Queue work finished with status. Nice. Queue on submitted work done. Okay. So if I say queue dot yeah, let's see what we have here. Copy external texture for browser for on submitted work done. There you go. This is the callback. And in fact there is two here, interestingly. And one of them is actually a future, which I think is using C++ async. Though I don't really have any experience with async, so at least in C++. So, but that would be interesting to try out, honestly. And I wonder if there's similar functions for the other ones that we have checked out. Like for example, is there like a adapter request device F? No, there isn't. So okay, great. It's only basically here. So on submit work done F. Oopsies. On submit work done F. So here we got this queue work done. WGPU queue work done status. Arguments callback info. I have two arguments. Okay, so it only expected WGPU, I guess, arguments. Keyword callback info. Okay, so it expected that. And of course this is in the WGPU namespace. Where's the two arguments? Weird. Too many arguments to function call. Expected single argument callback info have two arguments. Where is the oh, okay, I see. So this is totally wrong. Let's go with this. And this expected. What? Oh, you give it qwork done callback info. I see. Alright, I see. So you're actually supposed to give it that, and then you say callback. Okay, so here where you actually give it the callback, and the mode, and next in chain, and user data. And it actually returns for you a future, I think. Okay, let me see what I could do with that future. Let's see. There's only an ID, though maybe you could use it somehow. Yeah, just an ID. Well, anyways, we don't need it right now. So get Q, submit, and then we submit commands using the following procedure. Here, you give it the Q, number of commands you want to submit, and a pointer to the command array. In our case, it would probably take some sort of a span or vector or something. Just we're using C++ wrapper. let's see. So q.submit, it takes a command count. Well, it actually takes a pointer, right? So yeah, I see. So you gotta allocate memory for that or something like that. Anyways, we see typical idiom. Simply, okay, if we know it's compiled time, right, std array is safer. If we need to dynamically change the size, we use an std vector. However, we cannot manually create a WGPU command buffer. Okay, so commands, command buffer, and then you could submit the command buffer to the queue. Great. A command encoder is created, the usual object creation idiom. Okay, so command buffer, command encoder is WGPU device create command encoder. Great. And then you could also give it a label. Okay, let's try to create an encoder, I guess. Though, do you create it every frame or what exactly? I would guess every frame, maybe? I don't know. We can now use the encoder to write instructions, debug placeholder, and finally generate command from the encoder. Also requires an extra descriptor. Yeah, it probably just creates one encoder, or like more encoders every frame, but basically we record every frame. Yeah, just like Vulkan essentially. WebGPU backend Dawn. Encoder release, buffer release. Well, I have no idea how do you release that stuff. Well, anyways. Well, we could maybe find something about that in those samples, possibly. Where are the samples? Let's see. There you go. Okay. Well, they're actually putting them in unique. Like maybe release or destroy or something like that. Yeah, there's none of that. Interesting. C hello triangle, compute voids, CPP hello triangle. What about compute voids? Destroy, release, none. There's this Dawn utils. I wonder if I have access to that or something. But anyway, so yeah, let's go back now. Where? There you go. Okay, so I think every frame we create an encoder, then we basically submit that encoder. And oh, we didn't create the swap chain yet. Yeah, but this could be like used to actually fill buffers and stuff like that. So yeah. Alright, so but we don't need it right now. The CPU and GPU live in different timelines, blah blah blah. Anyways, alright, let's go. So the swap chain is the first step. Though in the browser, the swap chain is handled like by the browser itself essentially. But in native, of course, you manage it yourself. So swap chain description, here we give it the width and the height. It makes sense, as you can guess. We will have to take care of creating new swap chain when the window is resized. You may add GFW window hint, GFW false. Okay. By the way, this WGPU GFW, what it gives me other than setup window and get surface descriptor. Huh. Unique PTR WGPU change struct. Huh? Use for testing only. Does everything that creates surface for window. Does accept the call to create surface. Useful to be able to modify the descriptor for testing or when trying to avoid using the global proc table. Okay. So that's not for us. So that's basically the only function that is there. Okay. What else? So swap chain format, WGPU surface, get preferred format. Great. Okay, when using the Dawn implementation of WebGPU, it's not implemented yet. Ooh, get preferred format. I wonder if that's still the case. Actually, the only texture format it supports is WGPU texture format BGRA 8 UNorm. So it doesn't support sRGB. Interesting. Okay. So swap chain usage and render attachment. Immediate mailbox and FIFO. Okay. You can find or read in source code. Not a legal value, just here to force the inner line enum type to be a 32-bit integer. In our case, we use FIFO. Because FIFO is basically guaranteed to be always supported, at least in Vulkan. We may now create the swap chain. Great. And of course, at the end of the program, we destroy it. It's not exposed in the JavaScript version of the API, like the notion of surface that we have met already, by the way. Takes care. Okay. When calling create swap chain, creating window. Okay, great. Texture view. Okay, so let's actually create the swap chain, though we're gonna need to recreate it too. So how I'd like to do it personally is essentially by going to, well, first of all, let's have a swap chain here. I think, I'm not sure, I may want to put it in an option, I guess, or something. Maybe not, who knows. Let's see. Though the surface, we may want to recreate it if we want to support Android and stuff, but anyways. So now we got the swap chain. Okay, now let's go to so what we're gonna do now, basically what I like to do is, so we're pulling the events, right? Okay, and then we want to do the rendering, right? Okay, so but this is like the swap chain stuff isn't part of rendering, right? Okay, well, let's see. So I guess well, in app.hpp, other than the swap chain, I'm also gonna have a boolean should recreate swap chain. Let's go. And it would be false. Well, it would be true by default, I think. Yeah, so you can actually create the swap chain at the start. Great. And we're just gonna go ahead and should recreate swap chain. Okay, so how are we gonna do it? I don't know. Let's see. Void, I guess, prepare swap chain or something, or prepare frame, I guess. Or honestly, let's call this prepare swap chain maybe. I don't know. Let's see. And let's just generate definition for function prepare frame. And hold on, what? Prepare swap chain. Okay, great. So, oh, I see. So now what we're gonna do before, well, we could do it after, why not? And then we're just going to prepare the swap chain, and essentially we're going to render after that, and then we're going to present essentially. And for present, so these prepare, swap chain, and present wouldn't be called in what is it called? Yeah, in the browser, but the render would be called every frame, I guess. Or in fact, not even render, but we will have like, yeah, process, I think, app dot process, I guess. Well, I don't know, but we'll see. So just go right now with prepare swap chain now. So here we gotta say device, maybe create swap chain. There you go, create swap chain, and this would need the surface and the swap chain descriptor. Great. So surface and a descriptor. WGPU swap chain descriptor. Great. Though isn't there like some sort of, yeah, that function that they were talking about, which is in the surface actually, yeah. Get preferred format or something. No, there's only acquire and get. Yeah, doesn't seem like there is any of that. Maybe in the adapter, possibly. Let's see. Surface get. Yeah, no, it doesn't seem like. But anyway, we could just leave it as this. And the width and the height, this we would get it from the window. So GFW get frame buffer size and inch width and height. Great. And yeah, that's pretty much it to get the size. And here we're gonna pass the width and we're gonna pass the height. Though there is a problem here, what it is. From type int to uint32t. Okay, uint32t. Well, it's fine. Just static cast it or something like that. There you go. And yeah, let's go. We got the width and we got the height. Now what's up with this? Could now bind to another value of type WGPU surface. Yeah, there you go. Create swap chain. And yeah, what else? Present mode, FIFO, fine. There is high label, next in chain, present mode, usage width. That's it. Okay, great. That's pretty small stuff relative to Vulkan, but let's go. So right now, I think we should be able to get a swap chain with that. There you go. And we should probably check if it's null or not. So if not swap chain, we're gonna essentially fail to create WebGPU swap chain. Let's go. And yeah, if not swap chain, now let's see to make sure maybe. But actually, this would be called like every frame before we start rendering. And well, you gotta first of all make sure that we want to actually recreate swap chain. So if not should recreate swap chain, return. Yeah, and oh, I almost forgot. We gotta actually go ahead and say should recreate swap chain is equal to false to toggle it back. I think condition is always false. Well, it should be true by default, yeah. So, well, it already is. It already is. Interesting. Oh, what? If not, should recreate swap chain. Yeah, then should recreate swap chain, I guess. What? I guess true. What I'm doing. Yeah, no, return here, and yeah, I see. should recreate swap chain equal false. Let's go. Okay, nice. So why this? So we could handle the resizing. So when the resizing happens, you have to recreate the swap chain. Though, how would I actually know that it wants to recreate the swap chain? Is it just the resizing or what? Let's see what he have done here. Well, he didn't say so. Well, anyways. But we could handle it later, I guess. Alright, so this should actually create the swap chain at first. Let's see. Though I really need to figure out how we can make sure to destroy the previous swap chain. But anyway, get swap chain images, interesting. Create swap chain, let's go. Nice. Non-linear KHR. Okay, nice. So I think right now we have created the swap chain, pretty cool. So let's get to the next step now. So what it's doing here, swap chain get current texture view. Oh, okay, I see what it's doing. So it's gonna get the images from the swap chain now, so we can be able to, or should I say the texture of the swap chain, which is image view in Vulkan, so we can basically render to it. So if not next texture, that cannot acquire next swap chain texture. WGPU, view release, swap chain present. Great. So let's see. So we're gonna need this present actually, and we gotta also need, well, we could make it so this would give us the actual frame, I guess, or something. Let's see what it's done. There you go. So swap chain get current texture view. Okay. So what we could say in prepare swap chain possibly, but well, yeah, I'm just gonna do it like this. So if should recreate swap chain, then we're gonna do something. So if should recreate swap chain, we're gonna do this. Else we're gonna do something else. Well, actually we're not gonna do anything. And here we're gonna actually take the texture view. So let's say swap chain dot get current texture view. Great. Okay, and we're gonna return that basically, I think. Yeah, it gives us the texture view. Nice. So return, and here we're gonna say WGPU texture view. Though I'd honestly like to use the other method, the other style, which is auto, and just do this basically. But yeah, let's go back here. Auto, WGPU texture view, let's go. So I think that's it. WGPU texture view. And with that out of the way, we should basically be getting but also we should do that in the, yeah, we should honestly do that in the process function, because we're gonna compile out the prepare swap chain function in web. Yeah, actually that makes sense, right? Well, anyways, let's see, let's go back please. Yeah, let's go back. I forgot about that entirely. Let's go. There you go. And let's go here. Let's keep it as it was before. Void. And yeah, there you go. Okay. So now in this render function, or in this loop, yeah, let's say process, why not? And we also gonna need present though. Let's create a new function, present swap chain. I guess let's call this prepare frame or something. Well, anyway, fine. Let's call this present swap chain, and let's go here, app.h, prepare swap chain. And here we're gonna need void present swap chain, essentially. And in present swap chain, what we're gonna do, yeah, let's actually define this, and let's just say swap chain dot present there you go. And that's it for presenting the swap chain, and this is the one that's going to be called even in web, basically. So let's create that function. I'm scripting, hold on a second, I'm scripting event loop or something like that. I just want to see something. Main loop. Yeah, let's call it maybe main loop. No, anyways, let's just say process, fine. So app.cpp, and let's see what's happening here. Okay, great. Now let's say void process. And what's up with this? Generate definition function process. Okay, and here you basically gotta take the texture view. So auto texture view, current texture view. Okay. There you go. Failed to get current texture. Oh, well, no, we're not gonna throw. We're just gonna basically return. And we're probably gonna recreate the swap chain here though. But anyway, it's fine for now. WGPU command buffer encoder. Yeah, we're probably gonna use that. Set main loop. Okay. And then now let's go back to the tutorial. So if not, next texture view release. I really don't know how would you destroy stuff. Yeah, there's nothing about it here. I would guess it's using RAI, but I don't know. Anyways, probably gonna need an encoder now. Maybe, but let's see. At this point, it should hopefully be showing some black. There you go. That's what I'm talking about. Nice. Nice, nice, nice. Let's go. I wonder if there's any validation errors from Vulkan. Let's see if they're careful about that or not. Yeah, they are. Nice. So there's no validation errors. Amazing. And if I resize, there you go. So I'm not sure if it's working out. Invalid image layout warn. Yeah, I guess it's working out. Nice. Lovely. Though if we were not to recreate the swap chain though, you know what's gonna happen? It's probably gonna crash maybe. But let's see what's gonna happen. Beast. Okay, let's see. What's gonna happen if we don't recreate the swap chain? Great. Well, actually, we're not even setting this to true, wouldn't we? Yeah, we're not. I see. So, in fact, we should. But I don't know yet exactly what we're gonna use that for. Anyways, let's just ignore it for now. Fine. What's next now? Swap chain present. Great. Now the render pass encoder. Create encoder, command encoder, encode render pass, and finish encoding and submit. Nice. I love it. Render pass descriptor. Encoder begin render pass. Render pass encoder end. Okay. Describe the render pass. Okay, so we gotta create a command encoder basically, and then begin the render pass. Okay, let's do that. So in our process function, after getting the current texture view, we're gonna create an encoder, and finally GitHub Copilot got something right. And yeah, now what's up? Let's see. I guess, do I have to check for errors or something? I don't know. But let's just say, I want to call this command encoder, honestly. Command encoder. Let's go. And let's just say command encoder dot begin compute pass, begin render pass. Let's go. Copy texture to texture, copy buffer to texture, and buffer to buffer, and then finish. Set label right. Nice. Shouldn't we actually begin the command encoder thing or whatever? Yeah, there you go. Begin render pass. Descriptor. No member named in namespace WGPU. Render pass color attachment. Well, what is this? Render pass color attachment. Yeah, it's a pointer to render pass color attachment. So why this doesn't work? I guess it actually works. Does not refer to any field in type. Okay, so it's saying that this doesn't even exist. So I guess it's view then? Yeah, I see. So it's view instead. Well, let's just fill this on our own actually. And does this even work? Let's see. So do you really set this? Taking adders of temporary objects. So this doesn't work in C++. All right, interesting. So we're gonna have an array of attachments. So a CD array of WGPU color attachment, I think. Yeah, render pass color attachment, comma. I guess we're gonna have one for now. And here we're gonna say, yeah, we cannot do this in C++, only in C and Rust at least. So anyways, render pass descriptor. Great. So let's say the descriptor here. And let's just say render pass descriptor. Well, WGPU first. Let's go. Nice. Color attachment size, of course we're gonna oh, this is size T, so I guess this should be fine, maybe. Yeah. And then color attachment dot data. Great. Begin render pass. And now here I could actually create my color attachment, I guess. So I guess I have to say render pass color attachment, and now I could actually give it the stuff that I want to give it. The view, and what else? So what he's doing here, so he's, oh, by the way, let me not forget about the render pass end though. So where we're beginning, there you go, we're beginning the render pass here using this descriptor, which uses this color attachments. Okay, and then we're gonna end the render pass. Oh, I guess maybe this gives us a render pass encoder. Oh, I see, makes sense. So okay, let's say well, let's just say auto const. Do you have ideas for a game you want to make? Not really. Maybe a voxel game, but not really. So render pass. Oh my god, I forgot about something. Since I'm using C++, I'd better use this, otherwise I may have some surprises with copy constructors and stuff like that. Well, yeah. Render pass. End occlusion query, execute bundles. End. Nice. And do I have to end this guy too or something? Finish. It's kind of not too. Oh well, never mind. So finish. Here it gets command buffer descriptor. Okay. Command buffer descriptor. Yeah, GitHub Copilot isn't really helping that much with WGPU C++. Maybe it would have if I were using the C API, because there's just a lot of people using that. But yeah, that also happened to me with Vulkan. Like in the C API, it really very much helps. It gives you a lot of good suggestions, but in C++, especially if you use, like, let's say Vulkan HPP RARI wrappers or something like that, which not a lot of people uses, it just breaks. And especially it's kind of complex. And like C, which, you know, it's just like functions, variables, and yeah, that's it. Anyways, and pointers, of course. Autoconst command buffer. What is going on here? Oh, see what it's done there. Well, not what I really asked for, but okay, that's good. Command buffer descriptor. Let's see if we have missed anything there. What key on the keyboard do you use the least? No idea. I don't know. I really don't know. Caps lock out. Emperor screen. Yeah, all the keys on my current keyboard are pretty much very used. Maybe the keys like on top of the arrow keys, possibly. I don't know. But let's see. Command buffer descriptor. Yeah, let's go with, instead of auto, let's go with command buffer descriptor. Well, let's go. For me, it's gotta be right Windows or the menu key next to it. Right Windows key, I don't have that. And the menu key. Oh, I see. I never used that. Yeah, I see. I guess it's like left. Yeah, it's left to the control key, and I never even seen that. I never even knew that existed. So dot label. Yeah, this is not very interesting. Only label. I don't care about the label. At least in this case. So we could just give it null. So just command encoder.finish. So basically when you finish that, it gives you the command buffer. And then you can submit that command buffer to the queue. So we can run it, I guess. Exactly. So queue, command count 1, command buffer. And just to be good, gonna go with std array, WGPU command buffers, and then we could basically, I really don't know like why this wrapper is not very well, anyways, command buffers. Yeah, you have to do it this way, basically. Size and the data. Okay, great, fine. So that's the command buffer. Let's go. Though I could say command encoder to finish here, actually. Yeah, that's pretty much it. Does submit gives us anything? No. Makes sense. Alright, so what's next? Command buffers. I wanted to check something, but I forgot. Begin, render, pass, and end. Anyway, let's see what we have here. So that Lloyd OP. Okay, let's just check the tutorial now. Begin, render, pass, end, render, pass. I think I've already done that. Color attachment. Okay. Resolve target, that's for MSAA, for example. Yeah. And here we got Lloyd OP, which is clear and store, and the clear value. Yeah, depth stuff, and it's so out of place, weird spot that requiring right pinky. Also normally you open menu with right click because you moved the mouse there already. Guess the button's main purpose is for when mouse doesn't work. But even then, there's alt. Crazy stuff. Instead, the render pass can receive a set of timestamp queries. We do not use, is it in this example? Oh, so you could actually use this to like kind of measure the time that it takes for the render pass to finish. Nice. Lastly, we set next in chain to null pointer. Conclusion. Alrighty, so yeah, right now I just need these three guys. Lloyd OP, which is clear, so we can clear with a value, and then store, because well, we want the result of the render pass in this case. So Let's go load OP and store OP and clear color. Yeah, it missed this one. What it missed? Yeah, I see. Clear value it's called in our case. There you go. So yeah, and then here you set the color to something. Let's say red. And let's see if it works. Missing initializer from member resolve target. Huh. I mean, it should be... Yeah, it should be done. Hold on. Okay. Come on, bro. What the? Occlusion query set. Well, you know what? I'm gonna remove this guy. Missing field initializers. -w no. Oopsies. Let's do this and then w no instead. Error missing field initializers. Let's go. And yeah, I should be able right now to just don't care about that. What in the world? What? I'm super confused. And anyways, so there you go. We got it working. Resizing actually works somehow. Weird. But let's go. Okay, great. Great. So right now we can set this to whatever color we want every frame, essentially. So that's nice. Oh, it just shows the warnings basically, but without error basically, so I see. And yeah, let's go. Nice. So we could do, for example, something like, I guess, this. Sign of time. Let's see, but sign goes from -1 to 1, so let's decrease the magnitude by 2. So instead of, you know, being the magnitude of 2, because it's from -1 to 1, it would be just magnitude 1. And then we could offset it up. So instead of going from -0.5 to 0.5, we'd go from 0 to 1. Do you ever use float 16? Does that even exist? I don't think it exists in C++. I don't know. I legit did this same code today. What? What's up right now? 0. There you go. We got an animation. Let's go. Let's go. First animation, nice. Very cool. Okay. Though, let's see what happens real quick when we do something like this. Seems to be working just fine. Interesting. Okay, let's just remove this for now. Let's just say 0.1, 0.1, 0.1. Yeah, and we're gonna get to the next thing, which is to draw an actual triangle to the screen. Wonder how much time is left. Let's see, before I end the live. Yeah, there's still time. Okay, let's get to the triangle, I guess. Let's see. And depth stencil, blah blah blah. Okay. C++ wrapper. And here it's actually talking about the C++ wrapper, though this is like instance descriptor, instance create, instance comes with namespaces. Yeah, okay. And create instance, create buffer. Yeah, I don't think they're the same when it comes to the wrappers of WGPU. Of C++, sorry. Scoped enumerations. Exactly one of your source files must define WebGPU CPP implementation. I really didn't need that though. This adder is actually included in the WebGPU zip I provided to you earlier. I didn't need that in my case, or for some reason. But anyways, so basic 3D rendering. Let's go. Hello triangle. Input geometry. Well, we are for a ride. We're in for a ride. Well, anyways. So, vanilla WebGPU or with WebGPU HBB. Okay, great. That's very cool. In its overall outline, draw a triangle as simple as this. Select which render pipeline to use, and then draw an instance of 3 vertices shape. Great. Render path, draw, set pipeline. Okay. What is a bit verbose is the configuration, render pipeline, the creation of shaders. Oh my god, you haven't seen Vulkan. This is done only once when, or maybe you have seen it, who knows. When it's utilized in the application. Render pipeline. If you're familiar with OpenGL, you can see WebGPU's render pipeline is a memorized value for all civil functions. Yeah. Anyways, I already know all of this, pretty much, or at least probably most of it. So, create render pipeline. So, device, create render pipeline, then you give it a pipeline descriptor, okay. And then we got the vertex pipeline state, which currently we don't have any buffers. Okay. And then you also give it the module of the vertex, I guess, which is the shader. And then the entry point to the shader. Great. Constants. Okay. Primitive pipeline state. Okay. Topology, triangle list. Strip index format. Okay, and then the face orientation is defined by assuming that when looking counterclockwise for the win. Let's go. That's pretty much what you should use most of the time. Call mode none. You should probably go with back. I don't know why he said don't matter. It does matter. You're drawing 2 triangles. One of them is invisible most of the time. But anyway. But yeah, for a tutorial, it's probably a good, wise decision to go with none. So, anyways, fragment shader. Otherwise, if the triangle somehow ended up facing the other direction, you're not gonna see anything. You're gonna think that it doesn't work. Anyways, fragment shader. Fragment state, entry point, fs main. Okay, Stenthal depth state blending. Multi-sampling. Meaning all bits on. Yeah, basically inverted all the bits of 0, which would basically gives you, well, depends on that one. If it's U32, then it's gonna be like maximum U32 value, I guess. Default value as well, irrelevant for count. And the actual shader code. Has been designed to be a human editable version of SPIR-V programming model. So translation from SPIR-V to WGSL is efficient and lossless. Use Naga or Tint for this. What? I don't know. SPIR-V is more of an intermediate, yeah. Okay. Mostly used WGSL and C++. Oh well, WGSL is similar to Rust. So now here's the shader for our triangle. Okay, so he's basically having a p variable, and if the index of the vertex is 0, he sets it to this and stuff like that. Interesting. It would be better if he actually used an array instead of this branches conditions with the index of in vertex index. I may try that, but right now let's just go with whatever he have put here. Attributes. I don't really have any experience with WGSL, so that's gonna be a little challenging there. I usually use GLSL, so built-in position for more flexibility. Now simply store in a multi-line string literal. Creation of shader module. Alright, if def WebGPU backend WGPU. Okay. Interesting. And the pipeline layout. Null PTR. So null PTR would use the actual default pipeline layout probably that they have created that I've noticed before. in the Vulkan API dump. But anyways, conclusion, the render pipeline actually works. What's next? Okay, great. So I think first thing first is to actually load the shader from files. Load the shaders, yeah. So for that, the nice thing though is that it is one shader, so that's nice. Okay, let's see. So we got src, and we're probably gonna have like, I don't know, maybe assets or something like that. Maybe. All right, fine. Assets, and let's say directory shaders, and let's say triangle .wgsl. Let's install the WGSL support plugin. That would be nice. And let's actually copy and like paste this up, and let's go. Very cool. Okay, I'm dying to actually change this into an array, but I don't know how WGSL works, so for now I'm just gonna leave it as it is, not gonna touch it. So okay, let's see. So until now, I think that we have just done like the actual boilerplate, basically. Right now, where the actual, I don't know what to call it, but the actual customization takes place, kind of. But anyways, but for now, honestly, I'm just gonna hard code everything, I guess. Maybe. Yeah, so we don't go crazy for now. Yeah, let's just put it here, and we're just gonna put it though in the app itself. Who cares? Though I probably later on we're gonna put it here instead, maybe, but we'll see. So WGPU shader module, let's go. We're just gonna have a shader, I guess, isn't it? How much network programming have you done? Yeah, I've done pretty decent experience with networking because of Roblox and Godot, basically. So yeah, create shader module. Okay, so we're gonna need one shader. Nice. And what else? We're gonna also probably need a pipeline layout, maybe. Let's see. Yeah, we're gonna need a render pipeline. What else? Maybe that's it. Yeah, maybe that's it. So shader module and a pipeline. Render pipeline, exactly. And we don't have any buffers for now, where basically the vertices are actually hard coded currently in the shader itself, basically. So shader module and the render pipeline, great. Now let's go to app.cpp and let's say well, shader is equal to, well, probably device create shader module. Let's go. And here we're gonna need the descriptor. And yeah, oopsies. So the descriptor, WGPU shader module descriptor. descriptor. Here we only have a label and next in chain. So we're probably gonna need next in chain. Have you used the socket API non-blocking IU URIN? No, I haven't used the low level APIs yet. So I only use the high level APIs like init in Godot. Though not init directly. I know that init is like low level. But basically Godot init and Roblox high level networking job. So next in chain would be probably WGSL or something. Yeah, shader module WGSL descriptor probably. And yeah. Super fun stuff to give a try. Yeah. So WGPU. Yeah, I wanted to actually try init later on in a stream too. That would be cool. Like low level init. Okay, you give it the code. There's a const char. I would guess that code would be interesting. I mean, since it doesn't ask for a count, like how big is the code, I would guess it's gonna be like a null terminated string. So I would assume that. Like my goal was to be able to handle hundreds of thousands of connections simultaneously. Yeah, you'd probably need low level for that, low level networking. So yeah, code. Let's just say code. And here we're gonna need to load a file. Oh, let's go. Okay, interesting. It's showing me how to actually do an array in WGSL. Nice. So fn main built-in vertex index. Okay, built-in position. All right, nice. So here it's creating an array vic2 f32 comma 3 vic2 f32 return pause vertex index. Yeah, I'd like to actually try that later on, but for now let's just go with the. Okay, let's see. Who remembers how to load a file in C++? Okay, file system, I guess. Okay, let's include file system, I think. There you go. And then let's see. So std, I love how easy it is to read files in C. I love how easy to use in SDL. Like you just say load file, I think, or load string. I don't remember. Though in Rust you just have a utility function which is very handy. It's called, I guess, read to string. Like you just give it the file and it just gives you the string. That's it directly. But anyways, so file system path std file system current path. I guess that would depend on what is it called on GitHub Copilot for this to do the job, because it's something that everyone does, I guess. So let's go. That's what I'm talking about. And let's load that or include that. So let's make sure that it's doing it correctly. So here we got a path. It's taking the current path. Great. Probably the current path of the executable. Yeah. And then here we have. Can I change the working directory? Oh my god, look at that, how much targets there is here. Interesting. Okay. Let's see if I could change the working directory. Oh, there you go. Let's go. Nice. So let's set it to Kodotaku, and I think, yeah, that's, well, C-line projects, Kodotaku. Let's go this one, and let's apply, and okay. So then we're basically gonna say, what is this, by the way? Divided by or equal what in the world? Oh, I think I understand what it's doing there. Hold on, go back. Yeah, I see. There you go, that's what I'm talking about. Let's go. C++ moment. Yeah, divided by equal to, they've done it that way. I mean, it makes sense, but at the same time, sus. Anyways. Alright, so here it's actually creating a file in the path. Great. And brain damage. And then here we got an std string code. iStream buff iterator char from file. Okay, it's getting an iterator of characters from the file. Nice. And that's the beginning. And the end is iStream buff iterator char. Huh. Well, I guess this should work maybe. Let's see. Interesting. Initialization of non-aggregate type. Yeah, just give it code directly. Though I should probably convert it to a sister. C string. No matching constructor. Add last. Yeah, I would guess sister. Right? What? Requires 0 arguments, but 1 was provided. What in the world? Yo, how do you even define this? I don't get it. What? Bruh. What is this? Shader module WGS GL descriptor. That does not make any sense, does it? I guess maybe you create it first. Oh, hold on a second. What I'm doing here? Then maybe like this. .cscr. Yeah, that doesn't work out that way. Okay, what about WGSL descriptor? Ooh, what? Dot code. Okay. Okay, you should do it like this for some reason. Weird, but okay. Alright, so that's how you do it, I think. I guess. If not shader, throw, and let's go. If not shader, throw, and let's go. That's interesting. I guess it seems to be got You got loaded, I guess, maybe. Right, nice. Now let's go ahead and create the actual pipeline, I guess. Yeah. So for the pipeline, let's see, pipeline. So we're gonna say pipeline is equal to device dot create pipeline. Oh, I should call it render pipeline. Interesting. Though there's also an async version of this. Ooh, interesting. So you could basically, because well, compiling shaders takes a long time, or basically compiling pipelines takes a long time. So you could basically make it async. So like you could just tell it to start compiling stuff up, and when it's done, it's just gonna tell you. And while it's doing that, you could do something else. But anyway, for now, let's just do it like normally, like a normal human being. And yeah, descriptor. WGPU pipeline descriptor, render pipeline descriptor, I guess. Nice. And descriptor. And yeah. Next in chain. Depth stencil fragment. Label. Multi-sample primitive vertex. Okay, let's go with vertex first. In that, you give it the module shader. The entry point in our case is VS main, at least for the vertex. The buffers, we don't have any buffers. Is there anything else? Not really. Yeah, that's it for the vertex, seems like. And then the fragment, sure, why not? The module, same module. Entry point, yep, exactly, FS main. But what's happening here? What? Why the vertex state is getting by as a struct, but this one is taken by a pointer? What? Weird. Oh, there's this target, so maybe that's why. Maybe because it's kind of big, because of this color targets thing, maybe. But this is just a pointer, so I really don't understand the inconsistency here, but whatever. Targets count. Okay, we'll see about that. But first of all, let's try to fix this fragment state. Oops, what I'm doing here. Yo, what? Fragment state, let's go. Okay, great. Righty. And yeah, we probably need targets, color target state. Okay. What I'm gonna call them though? Color target state. Okay. Well, it's gonna be an std array, I guess. It's gonna be one. It's gonna be WGPU color target state. Color target states. Oopsies, I forgot one thing, which is the size, and it's gonna be one, I guess. And color target state. Color targets state, I guess. Or let's say target states in this case, yeah. WGPU color target state format. There you go. This should be like the, I guess, the swap chain format essentially. And then here, this should be in its own thing too. It's very annoying that C++ doesn't allow temporaries like this. C does, which very much makes a much more readable code, because all the information is in one place instead of, you know, pointers pointing to another thing, blah blah blah. Anyways, blend state. Okay. All right. Let's go. Previous initialization for field DST factor is here. This is very annoying. Anyways, operation src factor, src alpha. Yeah, what you have done there, this is basically to handle transparency, for example, but anyway, and blending in general, right? So transparency is just an example. So src alpha, yeah, there you go. Swap chain format, blend state, and color right, mask all. Nice. What's up with this? Okay, and we got the color in the alpha. So the color in the alpha, great. So src alpha 1 minus src alpha and add, then 0 1 add, zero 1 add. The alpha is configured as RGB. I guess this is for like handling. So yeah, this is the blending of the color and this is the blending of the alpha. Okay. Add the src, which is 1. The other one minus 0 source alpha. Well, let's just go with the tutorial, you know, so we don't have any surprises here. But I guess basically maybe this handles transparency better, something. Anyways, I can't really think great now. Anyways, 0 1 add. Okay, 0. Pretty sleepy. Just want to go get the triangle long. Yes. src factor, DST factor. Okay, add source alpha 1 minus source alpha. Great. Okay, so we got the blend state. Hopefully I didn't miss anything. Always the triangles. Yeah. The fragment state, primitive pipeline, blah blah. Anyways, so I think that's maybe it. Maybe. Blend, right mask format, nice. Is there anything interesting here other than that? I don't think. Yeah, no. Blend component, yep. What about here? No. Okay, great. So color target state, fragment state, descriptor, fragment. Oh, what's up with this? Oh, what? So fragment state, descriptor, create, render pipeline. Okay, anyways, primitive. Topology triangle list, good. And defined, good. Oh, I see. So this is like the format of the indices in the buffer, in the index buffer, right? Front face counterclockwise, great. Call mode probably back. But if something wrong happens, if we don't see any triangle, this is probably the bad actor. Call mode back. Great. Okay, what else? What else? Primitive fragment. Layout, no. Multi-sample. Per vertex. Do we really need to put a multi-sample? I don't think. Well, let's try this out, I guess. In used variable. Gabriel Borsiaga, welcome to the stream. Which is better, WebGPU or Vulkan? Depends on how you look at it. If you want cross-platform, surely you would go with WebGPU. If you want to go maximum performance and bleeding edge features, you surely would go with Vulkan. Well, of course, as long as you don't care about other platforms. Unless if you want to implement some other API for the other platforms, like for example, in web, you would implement, instead of Vulkan, you would use WebGL, or you would use OpenGL for other platforms, let's say, and you would use Mill for. But basically, yeah, the WebGPU does the work for you. But the problem with WebGPU is that you wouldn't get access to the latest features. I don't think they have implemented ray tracing though in WebGPU yet. I'm not sure. At least in WGPU, in Rust, I think they haven't done that. I'm not sure about this one. I'm not sure about Dawn implementation. But generally, any feature that is like recent, you wouldn't have it. It's usually like you would be stuck with the minimum set of features. But yeah, there is extensions. But yeah, you need an extension to use ray tracing with WebGPU. Yeah, basically. But for example, let's say buffer device address, or let's say dynamic rendering, or such bleeding edge stuff like mesh shaders. I don't think you can do that with WebGPU. And also the fact that, like, if you want maximum performance, you surely want to go with Vulkan. But again, Vulkan is only available in desktop and mobile. And even on mobile, you gotta have some, like, for example, you gotta recreate the surface. In fact, yeah, it's the same thing here. Yes, same thing here too, right? But it's, on the other hand, it's more verbose. Very verbose, more than WebGPU. But yeah, if you have any specific question about the difference between them, let me know. But I can't really think too much about the differences. But surely Vulkan is much more work. Oh my god. But basically, if you're gonna be caring about cross-platform, don't bother with Vulkan, I think. Tried both, and WebGPU is way too easy than Vulkan. Yeah, it is. Though I always would like to use Vulkan for to use the cool features like dynamic rendering, and I just like synchronization, and Vulkan API is pretty cool. But yeah, pretty much it's very consistent. Though this API, it's not very consistent. Sometimes they pass by pointers, sometimes they pass by struct. Though there may be some sort of reasons behind it, I don't know. But yeah, pretty much. But if you value cross-platform, surely go with WebGPU. If you value maximum performance and bleeding edge features, go with Vulkan. And in fact, in macOS, you don't really even you have to use Metal. You could use Mol and Vacay. It's just shoot in, honestly. But anyway, Apple products always suck. So yeah. Color target states. So I think right now we have created the pipeline. No? Oh, what's up with this? Error unused variable color. Oh yeah, there was some unused variable here. Color target states. Interesting. This is why you should make sure that warnings are enabled, because otherwise I would not have noticed that this is in used. So basically targets count. Okay, let's see. And let's find out if we have successfully created the pipeline or not. I would guess so, because they haven't thrown an exception. So yeah, let's go. We got a pipeline now. Nice. So what's up now? Let's see. I wonder how Metal is like. Now the thing is, I like how Apple have chosen to go with Metal, their own API, but at the same time I don't like it. So I don't like it because when you want to create cross-platform apps, macOS always suck. But I'm also a supporter of the idea of, just develop your app for your own machine kind of thing. Because basically, for example, the thing is, the more constrained your API is, the more constrained your, the less scope you have, the better. For example, in Vulkan, you have to take into account in the API a lot of hardware, even older hardwares. And that's why it's super bulky, super verbose, and a lot of times very annoying. For example, let's see. For example, render passes and bindings and descriptor sets. All of these things are just garbage. They're not needed for desktop. Their render passes are needed for Android, not Android, but mobile in general, and basically anything that is not desktop mostly. But of course that depends. But really, render passes are very important for mobile though, and not for mobile, but basically for tiled GPUs, basically. And most mobiles use that because it's very power efficient. Since basically, well, let's not go into detail right now. And what else I wanted to say about it? Yeah, basically Vulkan have to take into account all of this stuff and also all of these platforms and stuff like that, which, as you can see, results in such a very verbose API. But when it comes to Metal, their only target is their own thing, their own hardware, their own OS, etc. So I would probably think that Metal is probably very nice to work with. So it's probably gonna be straight to the point, because, well, it doesn't have as much scope as Vulkan is. Tal GPU said, what's that? Tal GPU. Well, it's a long story, but let me try to give you just a little description about it. But essentially, the gist of it is that in mobile phones, mostly, or embedded in general, memory transfer is very power hungry. In fact, in general, memory transfers are very power hungry. And the thing is, in desktops, you gotta actually copy around stuff up, right? Gotta copy frame buffers, or whichever you want to call it, right? But in tile GPUs, what happens is that like your frame buffers, I think, are like what is the partitioned? Yeah, they're partitioned into tiles, and each tile have its own backend memory. So you don't have to like if you have multiple subpasses, which would work on the same tile, you wouldn't have to copy that frame buffer into memory and then fetch it back from memory. I would just work on the actual tiles memory, which is kind of like more cache. It's like the cache basically. So yeah, while in immediate mode they don't have that. They just copy to memory and copy back if they want that. Though the actual difference, well, not the actual, but basically what happens is at the start they have like a binning phase where they just like see the vertices and like the actually not the vertices but the primitives. Basically they see where the like which tiles would actually work on those primitives. That's the binning phase, and then yeah, and it just works, I guess. That's why on mobile you should actually separate your position buffer. Like your vertices should the positions of the vertices should be separate from all the other stuff, because those positions are the ones that are actually being used in the first phase, which is the binning phase, which they partition the primitives into the tiles basically. Do mobile GPUs share main memory? I don't bother with Metal, who in the world play a game in macOS. I know graphics are not just games, maybe a GUI, but why just doing an app for macOS when you could make it a lot more platforms? Yeah, pretty much. But what I'm saying is that it like since Metal only like targets their own stuff, like the scope of the API is very small, then it's probably gonna be very I don't know, like comfortable to work with, I guess. But anyways, so GPUs share main memory rather than having dedicated VRAM. Not sure about that. Probably they do have their own VRAM too. Maybe not. Nah, I don't know. I don't know about that. But basically the gist of it is that the frame buffers have, like in tiled GPUs, the frame buffers have their own memory. Every tile have its own memory, which could be used if you're using multiple subpasses. So basically, if you're on mobile, you can have more performance if you use subpasses instead of, you know, multiple render passes or just dynamic rendering essentially. But yeah, anyways, okay, so we have created the pipeline now. So what's up with that now? We gotta set the pipeline, I think, in the command encoder. Yeah, I think, well, yeah, the tutorial doesn't seem very linear though, I guess, isn't it? It's going, yeah. So why put this code here? And anyways, set pipeline and draw. Okay, let's see where we are. So begin render pass. Okay, here between begin and end, then we're gonna set the pipeline and then we're gonna draw. Let's go. That's how much instances. They put the draw call at the start of the page. Yeah, I have no idea, but I guess they're going top down style. But yeah, anyways, so let's see if that works. Hopefully, yeah. Let's see. Well, there you go. That's what we're talking about. Let's go. Nice. But you can notice that it doesn't have multi-sampling. So it's pretty rough geometry. But yeah, there you go. It actually works. Nice. But it's kind of weird. Oh, there you go. It's broke. Yeah, there you go. Right now it broke because we're not handling swap chain recreations. But at least it doesn't crash, which is interesting. Invoking it would crash if you don't handle it well. But maybe I could handle it with, well, at least for now. I don't know exactly what is the actual procedure to work with here. But let's just for now do what is obvious, which is to just set the GFW callback. So let's see. Set window user pointer. Yeah, we're gonna need that. Good call. What's up with this? Misleading identification. Oh, I see what you're talking about. Okay. And what else? Set frame buffer size callback. Great. Static cast. Oh, I see. Nice. Auto app, static app, GFW set window user pointer. Nap should recreate swap chain true. I mean, coming to think about it, I think it would be nice to actually use closures instead of these functions. Yeah, honestly. I don't know why I have chosen to use those instead. But anyways, so basically should recreate swap chain equal to true. Let's go. We're not going to be using width and height here. Okay. Well, we could indeed go ahead and set the width and the height. Yeah, sure, why not? So we could say should recreate swap chain true, and then we could say int. Is it int? Yeah, I think so. Width and height. And then basically we're gonna set the app should recreate window. Okay. And then we could set the app width to width. I wonder how many Turing complete components C++ has. A lot. Well. Width and height. It's crazy. Let's see. Should recreate swap chain. But I should not forget to actually set the frame buffer size at the start. I wonder if I could call the size callback. Well, I could do something pretty interesting, which is resize callback, and then here I guess autoconst resize callback. There you go. And then I could call it. And there you go. Let's go. So that's nice. Because this would only be called when the window gets resized, but we also want to update these stuff at the start. But the thing is, let's grab these guys. We don't need them anymore. Here. So these would just use the members. And then I should just make sure to get that and put it in here. We need that at the start, and let's go. So it kind of like simulate an event at the start, I guess. So anyways, let's see if that would work. Ouch. Rich. There you go. Nice. Oh, what the? What? Very weird. Reap. No idea. Yeah, he's probably gonna mention how to fix it later on. So, hello triangle. Oh well. Well, I think maybe I know why, possibly. Maybe not. Let's see. Well, present swap chain. Does this return anything? No. Okay. What about this one? Okay. So, please, when this happens, tell me. Failed to get current texture view. And let's see. Yeah, set diff vertex colors. Vertex colors. Oh yeah, I'm gonna do that. Sure. Let's see what's gonna happen here. What's up with this? What? Sometimes it works, sometimes it doesn't. With my Vulkan knowledge, I kind of know maybe why that's the case, but I have no idea. Let's see. Bruh, come on, what? Right now it just works. What? I'm super confused now. Weird. Anyways, so for some reason it just worked. I don't know. But yeah. Anyways. Not current texture, return. And yeah, let's actually try that you said about, which is, so the first thing that was kind of killing me to change is this. The tutorial have done it like this using the condition, but you could have easily used an array instead. GitHub Copilot have shown me that before, but yeah, you have shown me that before. Let's see if you can show me that again. Let's see, you have shown me that here, around here, yeah. So basically, let's pretend that this doesn't exist. And let's just pretend that we're gonna create a code here. And hopefully GitHub Copilot would say, there you go, that's what I'm talking about. Okay, so this is how you create an array in WGSL, I guess. Alrighty. So let's just copy this whole thing actually. And let's go. So we don't need this now. And yeah. Now let's go here. And instead of this craziness, let's go. We're gonna do this. And we don't, well, okay, and let's see if this would work. Right, so var pause 3 vertices, vic2 f32. Yeah, they should possibly work, though the vertices are different here, but let's see. Yeah, the vertices are probably in clockwise order, maybe. These are the vertices that are suggested by GitHub Copilot, so I'm curious what it would be. I would guess a triangle, but let's see. Oh, okay. It doesn't actually work with that one. But yeah, let's try these vertices that we have here instead. And it's raining, interestingly. Oh, okay. What in the world? Okay, I see. So hold on, go back. Should be like this. There you go. Oh, what? It's the same thing? Is it really the same triangle? What? Yeah, I guess it's... yeah, just a bit different, right? In the order, I guess. Anyways, so that works. Nice. Lovely. So that's how you create an array in WGSL. Let's go. And that's pretty cool. Nice. So we don't need this anymore. And that's the pause. Now we could also do the same thing, hopefully with colors. But I'm not exactly sure. Does it rain often? It's very random, honestly. With because of climate change, it's very random. Seasons are messed up. So yeah. Pause in vertex index. Though I wonder if I really need these. No, I don't. Interesting. What about this? Do I really need it? I guess I do. Okay. What about this? Can it infer it or something? Nah, probably no. But what about if I said this? Like Rust, maybe? No. Yeah, I don't know. You could use just, oh, array. How? I guess, do you mean maybe like this? Doesn't seem like. Or maybe like this? Doesn't seem like to. Yeah, no. But weirdly enough, it doesn't give me any error. It doesn't. Weird. But anyway, let's just go back now. And I'm not sure how to pass stuff from the vertex to the fragment. Yeah, how to do that? Let's see. WGSL pass vertex to fragment. Or just some examples or something. Though I think WGPU does have more examples there, so possibly we could learn something there. Let's see. So WGPU, okay. Examples, let's go. Hello triangle. src shader wgsl. Nice. Okay, they're using that compute way, like, I see. Basically they're doing some magic here to compute it. But yeah, it doesn't really, it's just super unreadable for no reason anyways. XY location in vertex index. Okay, what else? Let's see. Hello triangle, cube, but it's cool. So shader wgsl cube. So this is the cube. Okay, so vertex output, interesting. Text chord. All right. I see. So in the fragments, seems like you could get the vertex output. Are we getting that? No. Okay, so let's actually do that. So you get the vertex output, then you create an, I guess, a struct called struct vertex output or something. It doesn't matter, probably. Maybe. I don't know. Okay. Location 0 text chord. Built-in position. And currently it's actually built-in position vic4f. I see. So I guess we could do something like this, and it would be the same, maybe? Yeah, I would guess maybe it could be the same now. No. I broke it. It's very weird that it doesn't give me any error. Maybe I'm not checking something. Return. Oh, okay, I see. So you actually had to do it like this. Var result. Okay. So result dot position. There you go. Yep. I think that should work, maybe. There you go. Okay, right now instead of that, just that, right now we have a struct that we could add anything to, which is nice. Built-in location 0. So I guess I could say location 0 and add the variable that I want. Okay. Or in fact, I don't really need to. I already have the position, so I could use it here. Great. We can't use SPIR-V with WGPU, right? Yeah, but there could be some extension. Yeah, there could be some extension. I mean, yeah, I've seen that actually. Hold on. I've seen it here somewhere. Hold on. Yeah, there you go. SPIR-V descriptor. But maybe it couldn't work on all platforms. Like, who knows? Maybe there's some caveats to it. But basically, in fact, why they did a whole shader language in the first place is so they can make sure to translate it well to all the other stuff, like for SPIR-V, for Vulkan, and MSL for Mac OS, etc., etc. I think, at least. But anyways, so here let's try to do something. Let's say vertex.x, and here maybe vertex.y, and here let's say 0. I guess. Let's see. Uh-oh. What happened? Interesting. Well, these are from minus 0.5 to 0.5, so that could be an issue maybe. Oh, what I'm doing. The position. And yeah, I'm probably gonna end the live stream very soon. Well, there's still some time though. Okay, let's see. We can use SPIR-V in the browser, so that's because they created WGSL by thinking native apps. We could use SPIR-V. Yeah, for native apps, surely, as long as it's on Vulkan. But, well, anyway. There you go, but what? Nah, that doesn't work as expected. It doesn't like interpolate it. Or maybe it does, but something is wrong. Yeah, why is it yellow? Good question. I don't know. Since it's yellow, then probably verb position X and Y are 1. Or at least interpreted as 1. So why that's the case? No idea. No idea. Not sure if I missed something here. Return vec4 if32. Okay, so well, how we're gonna do this? Well, since this doesn't work out, yeah, fine. Let's try something else. Okay, let's try something else. Let's say location 0, I guess. Color, or not really color, let's say index, I guess. And this would be E32, I guess. And then we could say result the index is equal to in-vertex index. And then hopefully we could do the same thing here maybe. Actually, no, not this way. Hold on, what I'm doing. No, color vic4. I guess vic4 if32 maybe. And then what we could do, or we could say actually vic3 maybe. Well, that's fine anyways. Just use colors equal array. Array vic3 vic. Yeah, I'll see. Hold on. vic4 vertex shader. So here's what we're gonna do. We're gonna say color here. And well, yeah, let's just go with vic3 actually. And we're gonna have this as 0, 1, 0, 0, and yeah, stuff like that. Oopsies, vic3. Alright. Let's go. And now what I could say is result.color in vertex index, and hopefully this works. I'm not sure if I'm allowed to just give result.color like this, like in GLSL. So I'm just gonna go the safe way, which is result.color.x, or maybe R. Not sure about WGSL. I would guess .yz. Nope. Something is wrong. That seems interesting but quirky at the same time. Yeah. Vertex output, result position, fragment, fs main. I really don't know. What about putting this here maybe? Weird. I honestly don't know. So let's just remove that. Okay. Okay, I guess some random error that's completely unexpected. Color is a fig4 for his setting to an array. Anyway, so this works. Let's try to maybe see other stuff. Source C. Conservative raster. Though something that I noticed is that you could probably do this instead. Yeah. And this. Okay, let's see something else. Oh, non-uniform indexing, interesting. Yeah. Yeah. I wonder right now what is next in the tutorial. Let's check it out real quick. Though at this point I'm very tired. Let's see. Just gonna see what's next. So we got a triangle now, very cool. Next up would be the input geometry. Plane with buffers, the first vertex attribute, multiple attributes, index buffer, load info file. I see. Plane with buffers. I wonder if that would be quick. Let's see. Right into a buffer. Reading from a buffer. Synchronous polling. Yeah, no, let's leave it until later. Pretty much. So yeah, that was it for today's live stream. I'm probably gonna live stream again tomorrow to continue this. It's very interesting. So yeah, see you later, guys. Goodbye, everyone. Have a great day or night.